Okay, here I'm going to look at three kinds of natural selection. While in general, the natural selection process is all the same, there's actually three ways you can classify how a population is shifting. So the first one is stabilizing selection. In humans, infants with intermediate birth weight have the highest rate of survival. As we see here, we see our birth weight and our infant mortality. So our infant mortality decreases dramatically, but then actually heavier babies can also be at odds for infant mortality. In chicken, eggs of intermediate weight have the highest hatching success. What this stabilizing selection is the before, it's just a normal kind of curve here, and the after has a little bit steeper incline and that kind of more of that peak. So just comparing here, your percent mortality, odds are, if you find out what you weighed when you were born, odds are you're probably right around 7-ish pounds, a little bit more, a little bit less. That doesn't mean every individual below 2 pounds dies. It just means that the likelihood of mortality is increased. Another type of natural selection is called disruptive selection, where before we had this mean, and this could be kind of like the gray rabbit here, and then all of a sudden we get this selection for two ends of the spectrum. With bird beaks, the intermediate bird beak could be a disadvantage, could be unable to open large seeds and too clumsy to open small seeds. Sometimes that middle ground is not the advantage. So in this case, you either want to be a black rabbit or a white rabbit. The gray ones, for whatever reason, not advantageous. So this just shows this disruptive selection. We're taking our mean and selecting for basically both extremes. Then there's directional selection. This is where we're taking our mean and we're shifting it towards in this case, the right. Flies that flew towards the light were eliminated from the population. Therefore, the remaining flies mated and the experiment repeated for 20 generations. And we're selecting for, in this case, flies that were unattracted to light. This is shifting the mean entirely. So what once was a very low percentage of the population now becomes the mean or the average. And this is directional selection. So these are the three types. This is another graphical representation, again showing that disruptive selection are before population, and then we're selecting for both extremes, as indicated here, where for whatever reason this tan is not the best color. You want to be a darker or lighter color. Our stabilizing selection, where we're noticing that middle is the best or favored upon, and we're selecting against the extremes. And then directional selection, where once our population might have been short, now we're shifting towards a taller population.